Going through Module 5, some of the calculator skills related to the least squares regression line. We're going to talk about how to make a scatter plot on your calculator, how to come up with the equation for the line of best fit, and how to create a residual plot. So first thing we're going to do is use this track and field data from lesson 4. So go ahead and put that data in. So we're going to go to stat here and go enter. And in list 1, please put all the sprint times. In list 2, all the long jump distance times. So take a second and do that. You might pause the video here, but I'm going to keep moving forward. First thing we're going to do is make a scatter plot so we can visually look at the association between these two variables. So to do that, I'm going to go to stat plot, which is this menu right here. But first I'm going to make sure that I don't have any pre-calc or algebra 2 stuff in there. So I'm going to hit y equals, and whatever stuff you have here that you might use for your other math classes, just clear that stuff out so that it's not there. Okay, and then we're going to go to second y equals, which will take us to the stat plot menu. So here we have the option to make 3 different graphs on our calculator: plot 1, plot 2, and plot 3. Notice plot 1 is on, plot 2 is off, plot 3 is off. If plot 2 and 3 are on, go ahead and turn those off. The way you would turn those off is just selecting them and going over to off and hitting enter. Okay, and then I'm going to go up to the top and go to plot 1. And this is where I'm going to set up the graph. So I'm going to make sure it's turned on. And here I have some options for some different graphs. So the first one here is a scatter plot. So the second one is a scatter plot where the dots are connected. So this might be like a time plot. The third one here is a histogram. The fourth is a box plot with outliers identified using the 1.5 IQR rule that you learned. And this is a box plot with outliers not identified, which I don't know why you would ever do that. And then here is it's called a normal probability plot. It's not something we cover in this class. So right now we're going to make a scatter plot. So I'm going to turn that on. And the explanatory variable goes in the X list here. So that's the sprint time. So that's in list 1. So second one here. And then the Y list is the response variable. Second 2 to get list 2 there. And then you know how, like, if you were using decimals or something, you might have to adjust your domain and range. So if you hit graph right now, you might not actually see anything because your domain and range are wrong. So instead of having to adjust the domain and range manually, you might use a command called zoom stat. So zoom here and down to stat, or I will affectionately call this zoom 9, will automatically size your window for you. So if I hit that, now the calculator decides on the domain and range and makes it so I can see this really nicely. And I can see that there's a nice negative association here between people's sprint times and long distance times. So people that tend to have really long sprint times tend to jump a really short distance. Okay, so and then we have an unusual point here, a fairly linear, maybe non-linear. We're going to look at a residual plot later to actually tell. And then this is pretty strong. So going through the FUDs there. So the next thing I want to do is come up with the equation of the line of best fit. So I'm going to go back to the home screen here, second quit. And there's something we need to do. We need to turn on a feature in our calculator. And we only have to do this once. So I want you to go to the catalog. So second 0 takes us to the catalog. This is a list of every command on your calculator. We're going to scroll down to the D's. I'm just going to hit the shortcut here for D. And that takes me down to the D's. And I'm looking for diagnostic on. Okay, diagnostic on. I'm going to turn this diagnostic on. Boom. And hit enter. Okay, now you will never have to do this again. This just turns on certain features that we need for our calculator. So don't worry about remembering those steps. I'm going to clear my history here so you can follow along. So now what we're going to do is come up with the equation of the line of best fit. So I'm going to go to stat and then over to calc. This is the same place where we used one variable stats before. But we're going to scroll down here to option 4 or option 8. Lin reg stands for linear regression. And These two commands, 4 and 8, do the exact same thing. The only difference is where A and B are. A here is the slope, B here is the y-intercept. In this command, A is the y-intercept, B is the slope. It doesn't matter which one you do, you'll get the same numbers. You just need to be attentive to which value is the slope and which is the y-intercept. So I'm hitting here, len reg, and the explanatory variable is in list 1. The response variable, list 2. Frequency list, we don't need that. We're going to leave that blank. We don't need to store this equation. Leave that blank. And we're going to calculate this. Okay, so here we go. Calculator uses the formulas to come up with the line of best fit. Our slope is negative 27.6. Y-intercept is 304.5. R squared you will learn about later in this class. R tells us the strength is there's a negative association, and being closer to -1 than to 0 tells us this is moderately strong. Okay, so that's how you do that. So the last thing I want to do is calculate a residual plot. Now, a residual plot is used to determine the linearity of this model. So when we just did this, our calculator made a list and stored it, the residuals in that list. So you see right here where it says list second stat. I'm going to go to second stat, and I just want to point out that you have list 1, list 2, but you also have this list of residuals. And this is where the calculator is storing all of these. So like if I wanted to take a look at them, like these are all the residuals. So the first point has a residual of 15.9, second has a residual of almost 19, and so on and so forth. So it only calculates the residuals if you do len reg first. So just remember, you have to do len reg, and then it will calculate the residuals. Now to make a residual plot, I'm going to go back to my stat plot menu here. So second y equals, and plot 1 again. In a residual plot, the explanatory variable is the same. So we're going to leave that as the x variable, which is sprint time here. But here on the y-axis, we want to graph the residuals. So we're going to change this from list 2 to the list resid. So remember the list menu, so second stat, and then we go down to resid, and now we've changed this to resid. And again, if you hit graph, you're probably not going to see what you want to see because the domain and range are wrong. So we need to hit our nice command, zoom 9, and boom, there's the residual plot. Okay, the x-axis is still sprint time, but the y-axis are residuals. So here's 0. Anything above the 0 line is a positive residual. These are all positive residuals. And anything below is a negative residual. So what we're looking for is random scatter. If this was randomly scattered, then we'd say, well, this linear model seems to be a pretty good fit. Points are kind of randomly above and below. But I don't see random scatter here. I see a kind of a curved pattern here. Okay, which implies to me that we should be using probably a nonlinear model. There tends to be points above the line, and then they go below, and then they go above again. This is probably a nonlinear model. We shouldn't have used a linear model. We could probably do better. Okay, so that's what the residual plot is for. Again, you're looking for random scatter. Random scatter is a thumbs up on your model being appropriate. It seems like here we should maybe go back to our stat calc menu, and instead of doing len reg, we might play around with some of these other regression, natural log, quartiles, cubic. There's lots of non-linear models here. We might see if we can find one that's a little bit better. Okay, so that's it for today. I would encourage you to go through all these steps again. There's just a lot that happened. Make sure you take good notes. See if you can go through this whole step again of entering the data, making a scatter plot, coming up with the line of best fit, and then graphing the residual plot. That's it for today. Thank you, everybody.